we're going to be using our all stations to central, and we're going to be looking at the signs, as in positive or negative, of each of our trig functions in there. So underneath that diagram, you will see this little table. Let's see if I can fit it all in. So starting here, it says quadrant 1. If I have an angle in the first quadrant, an acute angle, we call them reference angles, okay? Sine, cos, or tan of anything in that quadrant is always positive, okay? So it's just sine theta, cos theta, tan theta, they all stay exactly the same in that first quadrant and they're all positive. When we move into the second quadrant, theta, remember, is always the symbol that we give to our reference angle. It is the acute angle. So an angle in this quadrant, so using the example of 30 degrees, I go 180 minus 30 to get to 150 degrees. So sine of 30 and sine of 150 actually give you the exact same decimal on your calculator. They are the same. They are both positive as well because sine is positive in this quadrant. Okay, so this quadrant here, and you might want to write it on there, is called the 180, wait, draw for me please. It is called the 180 minus theta quadrant. So, sine of 180 minus theta is going to be the same as sine theta. It's the exact same as the reference angle and it's positive. So in there, if we squeeze it in, that's equal to sine theta. However, cos of something in that quadrant, it would have the same size. So let's say it was equal to a half in here. It will still be a half, but it will be negative because it's in the sine quadrant, not the cos quadrant. Okay, so we say that that's equal to negative cos theta. Everything else is the same, but it's just negative because it's in the sine quadrant. And the same thing happens for tan. Tan of something in this quadrant would be equal to negative tan of theta. So you can see by looking down this list, sine is the only one that's positive and the other two are negative. So we're going to follow that same pattern with these other two quadrants here. My third quadrant, remember these are numbered 1, 2, 3, 4, if you're going to number the quadrants. In the third quadrant, this is known as the 180 degree plus theta quadrant. Because again, if I use my 30 degrees, 30 plus 180 gives me the 210. We add that acute angle on. Remember, it always works from the horizontal line. Okay, so this is 180 plus theta quadrant. Sine, we're in this one, sorry. Sine of 180 plus theta, we're in tan quadrant now, is going to be negative. So that will be negative sine of theta. Cos of something in this quadrant is also going to be negative. So negative cos of theta. But tan is the positive one. We're in the tan quadrant. So tan of something in that quadrant is positive tan of theta. And finally, the fourth quadrant, remember we work from the horizontal line. This would be 360 minus theta quadrant. So 360 minus theta goes in there. Sine of something in here is going to be negative. Cos of something in here is going to be positive, but tan will be negative again. So let's write those in. Sine is negative, cos is the positive one, and tan is also negative in the fourth quadrant. Okay, so these are the formulas, but they are all based on that diagram. So if you are familiar with this, and if you're happy with the 180 minus and the 180 plus and the 360 minus, You don't need to necessarily have each one of these little formulas here memorized. You just got to work out which quadrant am I in. Is sine or cos or tan, is it positive in that quadrant? Okay, you can do it all from this diagram rather than memorizing them. It's up to you though. Some people like memorizing formulas. Okay, so what do we need to do? Examples on the next page. Example number 1. Decide in which quadrant theta lies in and state whether sine theta, cos theta or tan theta are positive or negative. So it is helpful to draw yourself a little diagram. Here is my little Cartesian plane. And remember that it's all stations to central, ASTC, going around there. Now remember that we drew rays in yesterday's lesson, and a 330 degree ray would be approximately there. So I've drawn my ray in the 4th quadrant, and that would be 330 degrees. So I'm in the 4th quadrant. Because it says, the first thing it says, they decide which quadrant we're in, so we need to write that down. 4th quadrant. Then the next thing it says is we need to decide whether sine theta, cos theta, and tan theta, we need to know whether they are going to be positive or negative for that angle of 330 degrees. So because we're in the 4th quadrant, it's the C for cos. Only cos will be positive there. So for the cos, we put a plus. I'm just going to put a plus for positive. And the other ones will be negative. Sine is negative, tan is negative. And that's all we need to do for this. We're just working out what the sign is. Let's do that again for B. We have theta is equal to 195 degrees. So on the diagram, a ray of 195 would be just slightly past the 180 mark. Okay, so all stations to central, we're in the tan quadrant. That is the 3rd quadrant. And again, we need to know the sign, positive or negative, for sine, cos or tan. So sine will be, we're in the tan quadrant, sine will be negative, cos will be negative, and tan will be positive, because only tan is positive in the tan quadrant. Okay, that was pretty good. Let's go to question 2. Write the following using their reference angle. The reference angle is the acute angle. So sine of 320. Again, I always recommend that you draw a little diagram for these. 320 is approximately down there. So that is a 320 degree ray. All stations to central. To find the acute angle, you always are finding the angle to the closest horizontal. So that means for this one, we want to find that angle in there. So we would do 360 minus the 320, which is going to be 40 degrees. Okay? So I've drawn that on my diagram. But what we're actually trying to find is another expression for sine of 320. Now, sine of 320 is going to be the same as sine of 40, using that reference angle. But, big but, what quadrant are we in? The cos quadrant. So sine of something in that quadrant is going to become negative. Okay, so we put the minus sign in front of it. Let's try that again. Cos of 115 degrees. Draw the diagram. 115 is in a 2nd quadrant, about there. 115 degrees. That's in the S for sine quadrant. We need to find the acute angle, which is the one going to the horizontal line. So that horizontal line is at the 180 mark. So if we do 180 minus 115, we would find out that that angle there is 65 degrees. Okay, we found the acute angle. So that means, back to our original question, cos of 115 is going to be equal to cos of 65, the acute, the reference angle, but is it positive or negative? Negative, because we are in the sine quadrant and we're doing cos, so cos will be negative. All right, one more. Tan of 203. 203 degrees is going to be slightly past the 180 down here. So all stations 2, we're in the tan quadrant. We start by finding the acute angle to the horizontal, the nearest horizontal line. We are in the 180 plus theta quadrant. We're going to have to go 203 minus that 180 to find that acute angle, which will be 23. So that means that tan of 203 is going to be equal to tan of 23, but check the sign. We're doing tan and we're in the tan quadrant, so it stays positive. Okay? Next page. Question 3. Find all quadrants where sine theta is less than 0. Less than 0 means negative. Okay? So if I'm going to draw my little all stations to central here, so we can just have a visual. Which quadrants is sine negative? That's right. Sine is positive in 1 and 2, the top two. So it's going to be negative in the tan and the cos quadrant, which is the 3rd and the 4th quadrants. Okay, just reading it straight off of my all stations to central diagram. Okay, part B says, where is cos theta greater than 0? Greater than 0 means positive. So cos is positive in the 1st and the 4th quadrant, which, so that's it. I want those two, 1st and 4th. Part C, find which quadrants sine is less than 0, so sine is negative. Okay, so sine's going to be negative in the tan and the cos quadrant, but also cos has to be greater than 0, so cos has to be positive. Cos is not positive here. Out of those two options, cos is only positive there. So using both of those restrictions, it's only the 4th quadrant that works for both of those situations. Okay, and part D, tan is less than 0. So tan is negative in the 2nd quadrant and the 4th quadrant. But cos is greater than 0. Cos is again greater than 0 here, but not here. So it's the 4th quadrant again. Any problems? Everyone's following along okay? Great. Question 4. Find the exact ratio of. Notice that word exact. Very important. Decimals are not allowed. Exact values. So for tan of 300, I'm going to be drawing a lot of these diagrams in this topic. 300 degrees is about there. Okay, so 300. Like we've already practiced, we want to find the acute angle, the reference angle. So doing 360 minus 300, I would find out that that angle in there is 60 degrees. So tan of 300 is actually equal to tan of 60, but I'm in the 4th quadrant, all stations 2 central, that's cos, so I need a minus sign. Okay, now we've practiced that part already. We have to go an extra step for this question. I want to find out what that is as an exact value, and that comes from our exact value triangles. These are on your formula sheets. So 1, root 3 and 2, this is 60 and 30, and the other triangle that we're going to need is the 45-degree one. So if I want to do tan of 60, tan is opposite over adjacent, so it's root 3 over 1 or just root 3. So when I put that into my equation here, I have a minus sign at the front, and the tan 60 is root 3. That's it. Okay? Let's try it again, part B. Now we want to find the exact value of cos 220. So draw our little diagram. 225 is going to be in the third quadrant. Find the reference angle. So I do 225 minus 180, and that gives me a 45-degree angle in there. To the horizontal, always go to the horizontal. So cos of 225 is going to be equal to cos of 45, but is it positive or negative? Negative, because that is the tan quadrant, and we're doing cos. So we need to put a minus sign in there. Negative cos of 45. Now we need to use our exact value triangle. What is cos of 45? Cos is adjacent over hypotenuse, so adjacent is 1 over root 2. So minus out the front, 1 over root 2. And I'm not expecting you to rationalize the denominator there. Part C, sine of negative 150. Remember that a negative angle means that we go in a clockwise direction on our diagram. So starting from 0, we come backwards 150, which would be about there, putting us in the third quadrant. So we find the acute angle. From that horizontal line, we do 180 minus 150 would give us 30 degrees in here. Sine of negative 150 is going to be the same as sine of 30, that reference angle. Is it positive or negative? We're in the tan quadrant, so it's negative. Now sine of 30 from our triangle. Sine of 30 is opposite over hypotenuse. So that equals a half. The minus sign out the front, minus half. Getting the hang of this? We're doing a few of these. This is very important that you can do it. Part D, sine of 600. We've gone over the 360 mark, which means we just need to subtract 360 off that so we can draw it in our diagram. 600 minus 360 is 240. So on our diagram, 240 is going to be in the third quadrant, like that. Find the acute angle, the reference angle. We do 240 minus 180 would make that 60 degrees. So sine of 600 is equal to sine of 60. Again, we're in the third quadrant, which is the tan quadrant, so that will be negative again. Sine of 60 from our exact value triangle over here. Sine is opposite over hypotenuse, so it's root 3 over 2. Equals negative root 3 over 2. And done. Question 5. Cos of 180 minus, cos of 180 minus x. Now the x is, well, normally we would have a theta, okay? It's behaving just like theta. That means that we're doing cos of something in the 180 minus theta quadrant, which is somewhere in here, somewhere in that second quadrant. Now, if this is the all stations, that's the sine quadrant. Cos of something in that quadrant is going to just be equal to cos, but negative, because we're in the sine quadrant, negative cos of whatever that angle was, the x. Yeah? All right, let's try that again. Tan of 180 plus x, that's the 180 plus theta, means that we're putting something into the third quadrant, in the 180 plus theta quadrant. That is the tan quadrant. So that would be equal to a positive tan of the reference angle, which is x. All right, one more question. This is going to be the good one. Question 6. If x, is that the last one? Oh no, sorry, then there's the graphs. There's one more question than the graphs. I know, the other one's the graphs.
Can you turn off the aircon or like turn it up? It's cold.
Oh, okay, sure.
It's just cold and it's a very cold day outside.
All right, question 6. If x squared plus y squared equals 25 meets the positive direction of the x-axis at A, find the coordinates of the point P on the circle such that angle AOP is equal to 30 degrees. Did you like that question?
Yes.
All right, easy. Okay, it's a circle. Start with what we know. We're going to draw this. X squared plus y squared equals 25 means that we have a circle with the center on the origin and a radius of 5. So there, 5 minus 5 plus 5 up there and minus 5 down there. There's my circle. So it says my circle meets the positive direction of the x-axis at A. I'm making an angle AOP, which is 30 degrees. So the positive direction of the x-axis means positive values of x. It's talking about from the origin, my x value is coming out this way. It means I don't want the negative ones. I want the positive ones on that side. So my 30 degree angle could be here. I could draw like that, 30 degrees. And if I draw it into, make it into a triangle, that would be a right angle. Looks familiar to some of the diagrams that we've seen. And that spot on the x-axis where it meets there is the letter A that it told me about. Now, it says that the ray, when it hits the circle, it meets at the point P. So we label that the P. And the O stands for the origin, which is the center of our Cartesian plane. So the question asks us to find the coordinates of that point P. So I know that my radius is 5. That could also be written there. There's a circle. It's going to be 5 the whole way around. But I do not know either of these two sides of that triangle. But I can find them because I have this 30 degree angle. And I can use SOHCAHTOA. So I'm going to call this one across here, because that's the x-axis, I'm going to call that the letter x, so I can find my x coordinate. So this is going to be x here, and then later on I'm going to find that one there, which is going to be the y coordinate. So starting with x. X is the adjacent, and the 5 is the hypotenuse. So if I use cos 30 equals adjacent over hypotenuse. Cos 30 equals x over 5. And I can find x. I just times the 5 across. That's 5 times by cos 30. And let's do this exact for practice. Cos of 30, using the triangle. Did anyone draw it on your page? Cos 30 equals adjacent over hypotenuse, which is root. Excellent, good job, Annabelle. So that's going to be 5 times root 3 over 2. Now, you could have done that as a decimal, but I thought we'd practice doing it exact. That's going to be that length of that line there. That's the x coordinate. Let's find the y one. I would use opposite end hypotenuse. I'm going to use sine now. Sine 30 degrees is going to be equal to y over 5 times the 5 across, and I get y equals 5 sine 30. Sine of 30 is equal to, look at the triangle, 1 over 2, a half. So that's 5 times a half which is either 5/2 or 2.5 if you prefer. So that means that the coordinates of P is 5√3/2 and the y value 5/2. However, the question said my angle had to be meeting my x-axis on the positive direction, but it did not say that it had to be above the axis. It could have been a ray 30 degrees below. So there's actually a second option as to where that point could have been. So to be thorough, we have to consider this one as well. So down here, that could have been the point P. And I would do the same thing. I make my right angle triangle. This is still going to be 5 here. And I'm going to have to find the x, which is going to be the same line as before, and the y. Now the x is actually going to work out the same. If you do, I'll do it in different color. If we do, let me write 30 degrees. 30 degrees in there. And I'll write negative 30 because we're below. If I do cos of negative 30, that is equal to adjacent over hypotenuse. Okay, that times that 5 across, that's 5 cos of negative 30. Now, cos in that quadrant is going to become positive, isn't it? So it doesn't matter that's a negative 30 degrees. What is cos of 30? Exact value. √3/2. And it's going to be positive because it's in that fourth quadrant. So that's, again, going to be 5√3/2. We kind of already knew that because that's the same length in that triangle as it is in that triangle. Okay, but we did it with the negative 30, so it was good practice. Let's find the y value. And again, you probably kind of got an idea of what's going to happen here. Sorry?
Wouldn't it just become negative?
It will just become negative. So let's see, it will become negative. It should be the same size, okay, because it's going to be the same length, but it is going to be negative because it's below. You're exactly right. Let's see how it works out with the math though. If I do sine of negative 30, I get y/5. So y is going to be equal to 5 times by sine of negative 30. But because we're doing sine in the cos quadrant, that actually would come out to be a negative sine 30. Sine 30 is a half, but it's negative a half. So that's 5 times by negative a half because we're doing sine in the cos quadrant. Yes? So that makes the minus 5/2. Okay? So the coordinates of this second point is going to be P is 5√3/2 and minus 5/2, much of which you would have been able to guess given that we've done the first one. But I thought it'd be interesting to look at doing sine and cos of negative angles. Okay, the graphs. If you did your homework last night, hopefully you drew some beautiful sine, cos and tan graphs, yes? So you need to be familiar with these curves. If I said to you, what does the sine curve look like? I want you to get to the point where you pretty much got it memorized. It starts at 0. If I talk about the origin, at the origin we start at 0, it comes up to 1, back down through 0 at 180, down to -1 and back up to 0 at 360. So you have that basic curve there. This is what you drew, hopefully, nice and accurately yesterday. You should also be able to memorize the cos graph. Sine and cos are pretty much the same graph. We call them a phase difference of 90 degrees, especially for those of you who do science and talk about phase differences. Okay, it's a 90-degree difference between the two graphs. It's the sine graph has been moved 90 degrees. That would be the starting sine graph there, wouldn't it? So it's 90 degrees out. Okay, and that coincidentally, a little bit of trivia here. You know how it's called sine? You spell sine S-I-N-E. And cos, the full word for cos is actually cosine, isn't it? It's because it's the complement of sine. Complement means adds to 90. Okay, there's that 90-degree difference between sine and cos. And you can see it there in the graph. Tan, however, is a much more interesting graph. And it has those asymptotes, which you can't see so well in here. So you should always draw on your asymptotes. So you've got one there at 90 degrees and 270 degrees. And on the negative side, we have them in there as well. So we have those asymptotes. And we discovered those when we were reading things off our boundary angles before. So in the future, with boundary angles in particular, we know our exact value triangles for things like 30, 60, and 45. But if I'm asking you to find an exact value of something that's 90, 180, 270, 360, it's easier to do them from these graphs. If I want sine of 180, I know my sine curve. Sine of 180 is going to be 0. Sine of 90 is going to be 1. Sine of 270 is going to be negative 1. Those are ones that you get from your graph. So you need to know those graphs really well. On the back side of those pages, don't turn it over yet. We need to be familiar with the cosec second cot graph. Now, cosec is the reciprocal of sine. So here's a cool little activity. Remember that you cannot, when you do 1 over 0 is where you get an asymptote. So if I do sine here, everywhere where there is a 0, I'm going to draw an asymptote there. There's a 0. There's a 0. There's a 0. And there's a 0. Now, if I take this point here at 1, 1 over 1 is 1. So my cosec graph is actually going to be right there as well. How about if I take a really small number down here? Right close, getting close to 0. What is 1 over a really small number? A really big number. So the curve is up here. It's going to come down and touch that 1. And then on the other side, because it's down here getting small again, 1 over a small number is a big number, it comes back up and makes this U shape. And it's going to be the same thing over here. At the 1, it's going to come up here and like that. For the negative ones down here, 1 over negative 1 is still negative 1, and they're going to be upside down U's that come down like that. And that is what I've drawn there in green. That is the graph of cosec. It is 1 over sine. And I've literally just gone through and done 1 over some values to get what that graph looked like. As you can imagine, cosec is going to do exactly the same thing, just with that 90-degree difference. Okay, so I won't do that all over again. You see it on the back of your page. Tan. Okay, let's try tan here. If I want to do cot, I need to do 1 over my tan graph. So again, you start with the zeros. 0 at 360, so there's going to be an asymptote there. 0 at negative 180, 0 at 0, 0 at 180, and 0 up here at 360. I'm going to start near the origin. 1 over a very small number is going to be a very, very big number. And it's going to, as it gets bigger and bigger here, so I'll put that in there, it's going to be very big here. 1 over this very big number. Max, can you write that down, please? You should be doing this.
It technically was decimal.
Turn it off. It's not the same. 1 over a very big number makes a very small number. So it is coming down and getting really, really small. In fact, it comes all the way down and it actually does hit the 0. I know that seems hard to believe, but remember when we're talking about 0 over r, and then we do the reciprocal and r over 0, and actually we do get 0 there. And then it reflects and it comes down, and it does the same thing coming down on the opposite side. So what happens is, I'll fill the other ones in, the asymptotes move over slightly, and the curves go the other way. because we've done the reciprocal of them. And that is our cot graph. Okay, so you need to know what they look like. Anyway, that's the end of what we need to go through today. You now need to have a look at exercise 6E, which we don't have much time for.